Question number 4. So we want to combine these two rational expressions and we're subtracting them. However, we don't have a common denominator, so we need to get one first. That will be our first step. So, I'm just going to copy both expressions before we get started. Incredibly enough, I can't write straight lines today. That wasn't too bad, but the first one, not too great. So we have x plus 2 down below and x minus 5. So to get a common denominator, in this case, I will need to just multiply the x plus 2 and the x minus 5. What do I mean by that? Well, if I have an x minus 5 over here and an x plus 2 over there, then we already have a common denominator. However, I can't just go on multiplying things like that like crazy. I will also need to multiply the top of the fraction here by x minus 5 as well. And it's nice to put parentheses around the x minus 3 here and the x plus 2 as well. And over here already multiply the bottom by x plus 2, so I need to multiply the top as well. Look at that. Now, we have x minus 5, or plus, sorry, x minus 5 times x plus 2, and x minus 5 times x plus 2, which is fantastic, because what can we do with this? I can just combine the two fractions now, all over x minus 5 times x plus 2 just once. Some people feel tempted to write them twice, because there's two of them, but, well, that's how combining fractions work, right? Once we get a common denominator, we just need to write that denominator once down below. And up top we have the x minus 5 times x minus 3, and we're subtracting the x plus 4 times x plus 2. Great. What do we do now? Well, we will expand and simplify these two binomials here, so x minus 5 times x minus 3, and I will skip that step, okay, just to move on here. Just why am I doing that? Just because I'm assuming that you are comfortable expanding and simplifying binomials. So x minus 5 times x minus 3 is going to work out to be x squared minus 8x plus 15. Okay? And minus, now we need to be careful with this minus. It's nice to put the answer in parentheses first. Okay? And I will do the same over here. I will just expand and simplify the x plus 4 times x plus 2. It's going to work out to be x squared plus 6x plus 8 all over x minus 5 times x plus 2. Now what do we do? Now we need to be really careful with this guy, again, the minus, because it will switch every signal inside the parentheses. So I will just copy this part, the first trinomial, over, so I get x squared minus 8x plus 15. And of course I'm running out of room. Then I will get, you know what, I'm just going to write this down below so I have more room. So x squared minus 8x plus 15. Now minus, x squared was positive, it will become just a minus x squared now. Minus positive 6x, so minus 6x as well. So all signals are getting flipped because of this minus here. Plus 8 becomes minus 8. All over x minus 5 times x plus 2. Now, can you expand this? You could. It's preferable usually to just keep it like this, non-expanded. Okay. Why? Just because perhaps we can cancel something out in the end. So now finally I can just combine like terms. X squared minus x squared is just 0, so they cancel out. Then we have minus 8x minus 6x. So that's going to work out to be, and I'm going to go over here now, minus 14x. negative 8x minus 6x, negative 14x. Then 15 minus 8 is just positive 7. Then all over x minus 5 times x plus 2. Then in this particular case, we're basically done. But one thing we could actually do is factor out a negative 7 up top. So, and why is that? Because we have 14 and 7. So if I factor out a negative 7, negative 14x divided by negative 7 is 2x. 7 divided by negative 7 is negative 1. All over x minus 5 times x plus 2. Now that's it. You can't do anything else anymore. So that's it. We're done.